Hi everyone, and welcome back to this second part of my tutorial series on creating a multiplayer game in Godot with Firebase. In the first part, we set up the Godot and Firebase projects and implemented a basic player movement, which is synced to the Firebase Realtime database. In the second part, we will implement the synchronization of other players to our local game instance. This part will be a bit more on the technical side. I've also written a blog post that covers this project in detail. You can find the link to that in the description. Now let's get started. In the previous part, we created a script to send our local player data to Firebase. If we now want to get the data from the other players in our game, we could theoretically request all players from the server every frame. However, this will lead to a lot of unnecessary data being transferred even when no player has moved, as the client cannot know that nothing has changed before sending the request. Instead of polling the server every frame, we can use the so-called server send events protocol. First, we need to send a request to open an HTTP connection, which will be kept alive while the game is running. The server will then send events whenever something in the database changes, for example, when a new player connects or a player moves. This is exactly what we need. We will only receive updates when something has changed in the game state. Now let's jump into Godot and implement this. In the script we wrote last episode, we added our Firebase URL as a constant and created a helper function to assemble the endpoint URL for our player. However, now we will need similar URLs to get the remote players in this part. We could just duplicate this code and create another constant in the new script we will create. Whenever you need to copy and paste the same code, it is a good idea to reflect and think about if it would be better to extract the common code into a shared script. Here it makes sense to create a global Firebase URL script that holds our host URLs and the helper functions to create the specific endpoint URLs, for example to load all players. So let's work on that. Create a new script and add the host URL from your Firebase project as well as the helper functions to generate the player URL. Another URL we will need is the one to load all players. We can already define that as well here. Now to access this variable and these functions, we can define this script as a global autoload script. Go to Project, Project Settings, Autoload, and then search for your script. Find the name for your autoload script and click Add. Make sure that the global variable checkbox is enabled. Now in our sync player local script, we can remove the host constant, as well as this get player URL function. Now we can use the functions from the Firebase URL script. Make sure to also change it in the send local player function. Now we're ready to start working on our remote synchronization script. Create a new node in the scene tree and add a new script to it. This script will be responsible for making the initial requests to the Firebase server and receive, parse, and handle the server sent events. The first thing we need to define is an HTTP client. This HTTP client will handle the low-level communication between our Godot and Firebase server. In the ready function we can set up the HTTP client by connecting to our Firebase host URL. Now we need to wait for the connection to be established. We can pull the status of our HTTP client in a while loop and wait until the connecting and resolving phases are completed. Once we're no longer in the connecting or resolving phase, we can check that our status of the HTTP client is actually connected. If the status is not connected, we print out an error message. Finally, we can send the request to start the server sent events with a post call to the player's URL, with the headers containing the specific metadata for the server sent events protocol. Let's add a print statement here to check that everything works as expected. One thing we forgot to do is instantiate our HTTP client. We can do that directly here in the variable definition. Another thing we need to be careful of are the slashes in the URL. So here, for example, I already added the slash to the host URL and also here for the player URLs. We actually only want it in one place, so either in the functions or here. Now we're finally able to connect to our Firebase server. In the process function, we can now check for new events from the Firebase server. We always need to poll the client to check for new messages, otherwise nothing will be received. We first check if the client has any response. If the client has a response, we read the body and make sure that it's not empty. Next, we need to parse the received body from a byte array into a string. Now finally, we can print the response and analyze what we received from the Firebase server. If you run the game, you can already see that we received 2 messages. If we now move the player around, you will also see that we get updates for the position of the player. We can now even run multiple instances of our game by going to debug, run multiple instances, and select run 2 instances, for example. Now you should see 2 different players in the events, and if I move one player, you will always see 2 updates. One for the first game window and the other one for the second game. Next, we want to parse our event data. In our response, we might get multiple of these events at the same time. So we first have to split the response into each event. The response might also contain a carriage return character, which we don't care about. So here we replace every carriage return character in the response with an empty string. Secondly, we split the response whenever there are 2 new lines next to each other. That way we will get each event part separately. Next, we want to loop over our response parts and parse each event. We can create our own server-sent event object that holds the data for our server-sent events. The type is a string which defines what kind of event we received, and the data is a dictionary. This we will parse from the JSON string of the event. First, we need to get the 2 separate lines for our event. So the first line contains the event colon name of the event, and the second line contains the data. We also make sure that we receive exactly 2 lines. Next, we want to extract these 2 fields from the response part. Let's define this event and data prefix as a constant, and then we can check and make sure that the first line starts with the event prefix and the second line starts with the event data prefix. So here we get the first line and make sure that it begins with the event type prefix. And here we extract the second line and check that it begins with the data prefix. Next, we can substring each line starting after the event prefixes. The event data string is in JSON format and we want to parse it into a dictionary. So here we try to parse JSON event data string. Finally, we can construct our server-sent event data structure. And then we return it. In our parse response event data, we can now check if the event is not null. And we're only interested in put event types. There are other event types such as the keep alive, which we want to ignore. Then we can add it to our event data list. Finally, to see if everything works, we can print our parsed events. In our output console, you can see the parsed event dictionary. That's it for this part of the video series. In the next part, we're going to work on getting the players to show up in our scene and update their position whenever they move. Stay tuned for this next part. If you like this type of content, please leave a like and subscribe. Until next time, take care.